Come in.
Hey, Francesca. How you doing?
Oh, I just finished washing this part I was frying earlier.
Did you know that a good example of the way in which humans take advantage of electronegativity every day is the flood? The PVP, which can coat a pan to keep your scrambled eggs from sticking to it.
I see, that's fascinating. I want to know more about it.
I can call Alexander and he can tell us more information about electronegativity.
Sure, let's do it.
Good day, we are Group 9 and we will be talking about electronegativity. I am joined by my group mates, Samuel and Francesca, who will be discussing electronegativity along with me.
So let's start by defining what electronegativity is. Electronegativity is the ability of an atom to attract toward itself the electrons in a chemical bond. It is not a measurable quantity but rather a comparable one. This plays a significant role in determining whether a covalent bond is polar or nonpolar. If we base electronegativity on a periodic table, it can be noticed that the higher the element is, the electronegativity increases. Also, elements on the right side of the periodic table also tend to be more electronegative. Some of the most electronegative elements include halogens, oxygen, nitrogen, and sulfur, while some of the least electronegative ones include alkali and alkaline earth metals.
There are three classifications when it comes to the bonds and electronegativity. When the difference of two elements' electronegativity is zero, it can be assumed that the bond is covalent. If the difference is greater than the two, the bond is said to be ionic. Lastly, when the difference is between 0 and 2, the bond is said to be polar covalent.
Let's look at some examples of classifying the bonds of each element. First, let's determine the bond in HCl. If we base it on the table above, 3.0 minus 2.1 is equal to 0.9, which makes the bond of HCl a polar covalent bond. Next, let's determine the bond for Kf. Based on the table above, 4.0 minus 0.8 is equal to 3.2, making it an ionic bond. Lastly, let's determine the bond of O2. 3.5 minus 3.5 is equal to 0, thus making O2 a purely covalent bond.
Going back to the coated pan, the polymer mentioned is a long chain of carbon-on-carbon bonds, where each internal carbon atom also has two fluorine atoms bonded to it. Of all the elements, fluorine is the most electronegative, so the bonding electrons are being held tightly to the fluorine atoms.
Okay, let's try one more example, sodium chloride. In this case, sodium has an electronegativity of 0.9 and chlorine has an electronegativity of 3. The electronegativity difference between sodium and chlorine is 2.1, and since this difference is greater than 1.7, one would expect the bond between sodium and chlorine to be ionic. Alright, that's all the time that we have today. We hope you learned something. Thank you for listening to our presentation.